I'm Anil Kumar, and in this video we will learn how to write explicit pattern rules. So let me take up an example and explain what I'm trying to say, right? So normally we may have a table in which we may have some input and some output. Let us say inputs are numbers like 1, 2, 3, 4, 5 and so on, and let's write some outputs. So let's say the output is 3, 5, 7, 9, like skip by 2, right? 11 and so on. So we do see a pattern. You could explain this pattern as start at 3. We can write this as start at 3 and then we say add 2 each time. So that could be your pattern rule. So let me call this as the pattern rule, right? That could be a pattern rule. How did we get to this pattern? So we say, well, start at 3, that's clear, right? So we start at this point. When input is 1, that is the starting point. And now to get how much are we adding, what we did was that we did, to go from one value to the other, 5 minus 3 is equals to 2. And then from here to there, 7 minus 5 is also equals to 2. And what we saw is that it is increasing by 2 each time. That is how we could write a pattern. Now this pattern rule is called implicit pattern rule. The problem with this pattern rule is that if I say that let my input be 100, then what is going to be my output? In that case, I have to continue writing this pattern up to 100 to get this result. That is time consuming. And if I say 1000, then what? It becomes extremely difficult, right? So there is a shortcut, and that is where this implicit pattern rule comes into picture, right? So that is where implicit pattern rule comes into picture. So the observation here is that 2 is important. You are adding 2 each time. Adding 2 each time is also same as multiplying by 2, right? What is 2 plus 2 plus 2? It is 6. 2 times 3 is also 6. Do you see that? 2 times 3 is 6. So, whenever we have a pattern which is increasing by a fixed amount, then we can understand it's a linear pattern where multiplying by the amount increased helps to find the formula. So we can find a formula. How? We know now times 2 will help us get the result. So if I do times 2, then I should get my result. 1 times 2 is how much? Well, 1 times 2 is 2, not 3. Okay, but then how can you get 3? You can get 3 if you add 1 to that. Okay, 1 times 2 is 2 plus 1 is 3. It works for the first number. You have to check it should work for others also, at least 2 of them. Then it will work for all. Okay, 2 times 2 is 4 plus 1, 5. It works. 2 times 3 is 6 plus 1, 7. It works. 2 times 4 is 8. 8 plus 1 is 9. So it will work for 100 also. So what we can do is we can do 100 times 2, 100 times 2 and plus 1. And that is the number which we are looking for. 201. So it works. Do you see that? So that kind of a rule which we did input-output rule, that output is equals to 2 times the input plus 1. That kind of a rule is called the explicit pattern rule. Do you see that? Immediately you can get your answer, right? If I say what is the number when we have 50 in this pattern? Well, that's for you to do. Times 2 plus 1, write down your answer. Do you see that? So that is how you could do this rule. Now let me make one more rule for you. This is just a practice sheet. Now let me share another pattern with you, and I hope this time you will be able to give me the result faster than me. Okay, let's write down the numbers. So input, let me take the same kind of inputs, 1, 2, 3, 4, 5. And what we need to find is a rule so that we know what is the output for 100 as the input, right? So, okay, so let me again start with some number. Let's start with number like, okay, 5. Okay, let it be, let's say 2. Okay, let's start with number like 2, but we'll go up by 5. Okay, so 2 plus 5 is 7, 5 plus 7 is 12, 12 plus 5 is 17, and then what do we get? Plus 5 will be 22, like this. We need to find what is the 100th number. When input is 100, what is the output? This is what we need to find. You can always use this explicit rule to get to this number. Okay? Now, first step is to find this difference. If this difference is constant, as it was in the previous case, then you can apply my method of finding the root. If not, then my method is not going to work. Remember that part also. So let's find the difference. 7 minus 2. So 7 minus 2 is 5, works. 12 minus 7 is also 5. And 17 minus 12 is also 5. So what we see here is that 5 is the common difference. We say common difference equals to 5. So I've introduced you to a new term here, common difference, right? So when I say terms, this is my first term, second term, third term, fourth term, fifth term. These are the inputs, these are the outputs. We want to find the value of 100th term, and here pattern is start at 2, increase by 5 each time. Well, that is a rule which works, but how do you find 100th term using your rule? That is the question. You need to find explicit pattern rule to get to this result fast. Let's see how. Now we understand adding 5 so many times is same as multiplying by 5. So I should try times 5. 1 times 5 is 5. How do I get 2? I get 2 by take away 3 from 5. Okay. Will it work for others? 5 times 2 is 10. Take away 3 is 7. 5 times 3 is 15. Take away 3 is 12. So it is working. Since it is working, we could apply with 100 also. 5 times 100 is 500. Take away 3. 497. Do you get it? It works. So that is how we could use our rule. So the steps involved are 2 to use my rules here, right? So first step is check common difference. First rule is check common difference, right? That is the first step. If it is constant, if constant, then times common difference. Right? So then times common difference is a part of our rule. We'll get the first part. Do you see that first part? Times common difference. And how do I get the later half? That is important to check. Common difference times what? What we do here is we don't apply the normal standard rule. We check with the value. So common difference was 5. Just check with your one number. 5 times 1 is 5. How do I get my output? So ask this question. Ask question. How do I get output? If you ask this question, you will get your answer. By adding some number, by subtracting some number, or what? That works, right? So let me give you one more example and see how it works really beautifully and very fast without doing much work. There is a different method also where you may have to rearrange, but at this stage we'll go with this. So input, output. This time let us write down the numbers as 1, 2, 3, 4 as before, and we'll again find, let's say, 50th number, and then we'll find 100. Okay, so numbers here you could start with let's say 6, and you want to increase, let's increase by 3 each time. 6 plus 3 is 9, 12, and then 15, and then 18, and so on. Now, since we increase by 3, we know the common difference is 3, right? So when you are going from 9 to 12, you're adding 3. So you have plus 3. Is that okay? You're adding 3 each time. So the rule has to have times 3 in it. Times 3, right? So we'll make a box here and say what goes into it. So what goes into this box is times 3. But if I do times 3 one number, what is the output? 6. How do I get 6? You can get 6 by adding 3. So we'll say plus 3. Do you see that? Try with the second one. 3 times 2 is 6. 6 plus 3 is 9. You get your result. 3 times 3 is 9. Plus 3 is 12. 3 times 4 is 12. Plus 3, 15. 3 times 5 is 15 plus 3, 18. 3 times 50. 3 times 50 is 150 plus 3, 153. 3 times 100 is 300 plus 3, 303. Do you see how you got your rule? Very simple. So that is how you can easily get your rule. Do you get it? So that is a way to find rules, explicit rules, from input-output table when we have common difference between each consecutive term. I'm Anil Kumar, and I hope that helps. In some examples, it may not work, right? So it works only when the difference is constant. Remember this part. In some examples, it may not work. But if it works, it's a very fast method to rely on. So that is why I'm sharing this video with you. I hope you appreciate it. You can always share and subscribe my videos. Feel free to post questions. And if you really like, put some likes. Thank you and all the best.